Good morning, dear student. I am welcoming you to my YouTube channel, Learning Again. Today, I have come up with lots of MCQs along with the answers, which is very much concerned with new education policy. Now, these MCQs are from Chapter 1, Class 12 Physics. This will help you a lot in the coming exam. So, without any delay, let us start the question and answering session. The first question is, how many electrons are there in one coulomb charge? Obviously, you know all this answer. Options are here. I'm not going to the options because it will take lots of time. So to make the video short, I'm not going to these options. So here answer would be 6.25 into 10 to the power 18 electrons. So how? To understand all those, we may go through like this. See, we know total charge Q equal to N into E. So here you see the amount of charge is 1 coulomb. So instead of Q we can write 1, and N is the number of electrons, and E is 1.6 into 10 to the power minus 19. So from here we will get N 1 by 1.6 into 10 to the power minus 19. I am showing you here how this answer 6.25 into 10 to the power 18 comes. So here we can write 10 by 16 into 10 to the power 19. So the answer would come 6.25 into 10 to the power 18. So now come for the next question. The SI unit of surface integral of electric field is, you may ask these questions by the SI unit of electric field. Let's see the options. Volt per meter, volt, Newton coulomb per meter, and coulomb per meter cube. So you know the answer. This is the answer, volt per meter. So answer may be, see shown it. This answer, suppose volt per meter is not there in the option, this answer may be Newton per coulomb also. The SI unit of surface integral of electric field is Newton per coulomb or volt per meter. Okay, because you know why it is volt per meter. E equal to electrostatic force by charge. The per unit charge, what is the value of electric force is called electric field. Again, E can be defined as dV by dr. That is voltage gradient. Means dV is volt and dr is meter. That's why the unit is volt per meter or Newton per coulomb. I hope this is clear to you. I will explain the answers because it will help you to get the basic ideas. Now come for next question. The value of charge Q at the center of two equal and like charge Q so that the three charges are in equilibrium. So what is that? The options are these. You might have not understand the question. Let me explain you. Suppose here in this point there is charge Q, and in this point there is charge Q. The value of charge Q at the center of two equal and like charges. So this, if it is plus, this is also plus. If it is minus, this is also minus. So plus like charges. So the distance between these two charges, this one, suppose. So if I put another charge small q here in the middle, so let the distance be x from here to here. So this distance would also be x. Now the question is, what is the value of this q should I put in the middle so that the three charges are in equilibrium? So to become equilibrium, the total force acting on the system should be equal to 0. Okay, so if I consider the q, see the force, if I consider this q charge with respect to these two charges, so force on this capital Q charge is F equal to the force due to this Q, K capital Q small q by x square, plus the force because of this capital Q on the capital Q. This will be K capital Q by 2x whole square because the distance is 2x. Now, this total force should be 0 for equilibrium condition. Now, if I simplify this, we will get q by x square equal to minus q by 4x square. On more simplification, we will get q equal to minus q by 4. So you see here the answer would be minus q by 4. So let's see the answer. This is the answer. Okay, so it will be minus q by 4. Now let us go to the next question. Before this, I should erase all this. Okay, now see question number 4. When an electric dipole is placed in a uniform electric field, it experiences forces as well as torque but no force, like this. Which is the answer? See, the question is, when an electric dipole is placed in a uniform electric field, suppose I'm explaining this question also. Suppose Suppose there is electrical line like this, like this. So if we place an dipole here, it experiences force as well as torque. Torque but no force, force but no torque, neither torque nor any force. So what will be the answer? Answer would be torque but no net force. Here we will add option net force. Force will be there because electric field is working in this direction, and this is the dipole moment, dipole Q. So there will be force in this direction and another force in this direction. So net force, these two force F1 and F2 are equal. So net force would be 0. But there will be a torque because of this force, because these two forces are working in the opposite direction. It will rotate like this. So this is answer would be option B. Hope the uh, questions you are getting very easily, right? Now the question number 5. VA and VB are 2 points on a equatorial surface. Then options are like this. You see, first of all, you have to understand what is equipotential surface. Equipotential surface is, suppose this is a surface, okay? If this point is A, this point is B, okay? So if the potential in this point A and B or in anywhere on the surface are same, then it is called equipotential. That is, potentials are equal in all the points on the surfaces. So potential at B at a BA, potential at B VB would be equal. So the answer would be this B. Hope this is clear to all of you. So answer is GB equal to BA. क्वेश्चन नंबर 6, यहाँ पे क्या बोला है, इलेक्ट्रिक फील्ड इज जीरो इन केस ऑफ चार्ज कंडक्टिंग शेल एट एनी पॉइंट. अभी चार्ज कंडक्टिंग शेल होता है तो उसमें क्या होता है, चार्ज कंडक्टिंग शेल. लेट्स सी द ऑप्शंस. इंटीरियर पॉइंट, आउटर पॉइंट, बियॉन्ड 2 meter, beyond 10 meter. The question is like this. Let us the answer will be interior point, but why? Why the answer will be interior point? See here, electric field is zero in case of charged conducting shell. Suppose this is a vehicle shell, okay? This is conducting shell. So the charges would be on the surfaces. If it is a closed surface and there is a conducting body, if I charge it, the charge would come on the surfaces. Inside, there will be no charge. No charge. So, as there is no charge, so inside this closed surface, there is no charge. So, there will be no electric field. As per Gauss law, you know, there will be no charges inside this. As per Gauss law, you know, the flux is equal to Q inside by epsilon naught, and also flux is equal to, we can write E into surface area. So if we equate this, we are getting EA equal to Q by epsilon naught. If Q is 0, then E would be 0. So inside this shell, conducting shell, there will be no electric field. Hope it is clear to you. Let's go to the next question. Question number 7. Before this, let us delete this. Okay. Now, the last question. Question number 7 क्या है? The dielectric constant of a metal is. देखो, dielectric constant of metal क्या होता है? Answer is infinity. बहुत होता है, बहुत. Now, आपका माइंड में ये आ सकता है कि then dielectric constant of non-metal क्या होगा? Yes, dielectric constant for non-metal varies for different material. Dielectric constant for non-metal is different for different materials. किसी किसी में 1, किसी में 0.1, किसी में 2, depends on the properties of the material. But if it is metal, then it is very high, infinite. Okay, let's go to the next question. An electron is sent in an electric field of magnitude this. The acceleration produced in it is. Options are this, this. So this needs to be calculated. So how? How can you find out this answer? So let us discuss this. We know that acceleration A equal to force by mass. You know that formula. So here you see force equal to, again you can write Q into electric field by mass. Now Q is electric constant for Q is given here, 9.9 into is Q, no, the electric field. Q for electron is 1.6 into 10 to the power minus 19, and electric field is given 9.1 into 10 to the power 6. So, and also the mass of an electron, what mass of an electron would be 9 point what? 9.1 into 10 to the power minus 31. So on simplification, this comes 1.6 into 10 to the power 18 meter per second square. So the answer would be option D. So I hope this is clear to all of you. Answer would be what? Not B. It is answer would be yes. Answer would be option B. Here it is domestically 3.128. So answer would be actually 1.6 into 10 to the power 18 meter per second square. Okay. So if you like this video, please stay with me and enjoy these videos. Okay, don't leave this video in between because it will be ultimately your loss only. I'm trying my best to make you understand with explanations all these answers. ये आपका बहुत फायदा होगा. So इस तरह से वीडियो देखने के लिए आप लोग मेरा चैनल को सब्सक्राइब कर लीजिएगा, एंड ऑल्सो यू कैन शेयर दिस विथ योर friends. Okay, let us go to the next question. The minimum amount of charge observed so far is very easy. You can easily answer this, because the minimum amount of charge means the fundamental charge, the electron. Electron we consider as the basic charge. Less than this, nothing is there. No existence of any charges below this. So the answer would be C. So without any delay, let us go for the next question. Okay, so next question is, if an electric dipole is kept in an uniform electric field, then resultant electric force on it is. We have got a similar question in the previous slide also. So here it is very easy, always zero. Because I have already explained to you that if these are the electric field, and if you place a dipole here, this is the electric field. So here will be one force, because this is a negative charge. If it is here will be two field, and another force will be in this direction. Okay, plus q minus q. So there will be F1 would be equal to F2. So net force F net will be 0 on dipole. So it is very clear to you. Let us go to the next question. The SI unit of electric field dipole moments are. The SI unit of electric dipole moments are. Is also very easy. No need to explain. The answer is centimeter. Cm, coulomb meter. Coulomb, not centimeter, coulomb meter. Okay, let's come to the next question. The term name electricity is coined from. The कौन सी वर्ड से ये आया हुआ है? देखो options are this. So answer would be Greek word electron, meaning ember or ampere. So no need to explain anything. Let us go to the next questions. Next question is, a soap bubble is given a negative charge, then its reading would be decrease, increase, remain unchanged, nothing can be depicted. देखो, अगर कोई soap bubble, suppose this is a soap bubble, it is neutral. If you put charge on this, you can be positive charge, either positive or negative. Whatever charge you put in this, see, if it is positive, then this should, the opposite to this should repulse it. This charge would push it, push it, push it, push it. So the size of the bubble would increase. It may, I have already told you that ये प्लस चार्ज भी हो सकते हैं, माइनस भी हो सकते हैं, पॉजिटिव नेगेटिव कुछ भी दो, ये क्या करेगा, ये पुश करेगा एक दूसरे को. सो इसका साइज जो है ना बड़ा हो जाएगा. सो होप इट इज क्लियर टू यू. सो आंसर इज इट इंक्रीजेस. नेक्स्ट क्वेश्चन, द मिनिमम चार्ज on an object is, it is very easy, because minimum charge would be equal to charge of an electron. So answer would be 1.6 into 10 to the power minus 19 coulomb. Now next question, a simple apparatus to detect charge on a body is the. एक apparatus होता है जो किसी भी बॉडी का चार्ज है क्या नहीं, आइदर नेगेटिव और पॉजिटिव कोई भी चार्ज हो सकते हैं, इसमें चार्ज है क्या नहीं ये डिटेक्ट करने के लिए इंस्ट्रूमेंट यूज करते हैं. उसका नाम क्या? वेरी वेरी इंपॉर्टेंट क्वेश्चन. तो नाम, ये नाम हो गया, नाम क्या होगा? नाम होगा गोल्ड लीफ इलेक्ट्रोस्कोप. ये कैसा होता है गोल्डी फिल्टरस्कोप? आई थिंक आप लोग सब जानते हो। ये ऐसा एक चैम्बर होता है। चैम्बर का अंदर यहाँ पे एक कॉर्क होता है, यहाँ पे दो एक मेटल होता है लोहा, यहाँ पे इसे दो फॉयल दिया जाता है और इधर से इसे कांटेक्ट। अगर कोई चार्ज बॉडी यहाँ पे आता है, प्लस चार्ज इसके कांटेक्ट में देते हो, तो ये चार्ज यहाँ पे चला आता है। सो बोथ आर सेम चार्ज, तो charge will come here plus 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 also plus plus plus, so this will repel, so this gap will increase more. If there is a deflection, then you understand that इसमें charge है. Okay, so I think it is clear to you. Now we can move for the next question. So what is the next question? Next question is, see, when some charges gets transferred to a conductor, it readily gets distributed over the entire surface of the conductor. But some materials are there on which the transfer charge stays at the same place. The name of this material, मतलब हम जानते हैं कि चार्ज किसी की बॉडी में अगर चार्ज करोगे कंडक्टिंग बॉडी में, सो ये क्या होता है, सारे सरफेस में डिस्ट्रीब्यूट होता है बराबर. इट रियली गेट डिस्ट्रीब्यूटेड ओवर द एंटायर सरफेस. बट कुछ मटेरियल है जिसको ये डिस्ट्रीब्यूट नहीं होता है, ये सेम जगह पे रह जाता है. ये क्या चीज है, कौन सा मटेरियल है? तो now see, the options are asbestos, gas particles, semiconductor, none of these. So answer is semiconductor. Now next question, 1 microcoulomb is equal to how much? So you know, answer would be 10 to the power minus 6 coulomb. Question number 18. A torsion balance is a sensitive device to measure what? Force, torque, inertia, या none of these. टॉर्शन से नाम, यू नो, टॉर्शन से पता चलता है कि ये टॉर्क के साथ रिलेटेड होगा, बट एक्चुअली इट मेजर्स फोर्स. माइंड इट. नाउ लेट्स सी द नेक्स्ट क्वेश्चन. नेक्स्ट क्वेश्चन इज, Coulomb's law states that force between 2 points charges, 2 points क्या होता है, varies inversely as the square of their distance and directly proportional to the product of the two charges, or this. You go through these options, so you know the Coulomb's law, so no need to explain this. Answer will be question A. Question number 20. Which mathematical formula represent the electric field? You know it better, so look at this and no need to explain, so answer is this. Question number 21. Mathematical representation of electric flux according to Gauss's theorem is. I hope you know this. No need to explain. Here you see phi. Phi is this phi is for closed, entire closed surface. Okay, this means closed surface. So phi E means flux. Closed surface EDS, this means the area vector. So it is cos theta, you know this all. So this would be, what is the answer? Answer would be option A. Okay, this is the as per the Gauss's law. Now come to the question number 22. Electric field intensity inside a charged spherical shell is. Inside बोला, inside बोला तो क्या होगा? Answer 0. Inside a spherical shell, electric flux would be 0 because you know charged spherical shell, so charge will come outside. Inside spherical shell, it should mention here the metal. Okay, If it is metal shell, that is conducting shell, then the charge would come on the outer surface. So inside there will be no charge. If there is no charge, then electric field intensity inside the charged spherical shell will not, that is zero. Okay, got it? Got it. Now come for the next question. In a uniformly charged sphere of total charge Q and radius R, the electric field E is plotted as function of distance from the center. These are the curves. So which graph is correct? You see, for your understanding, I am drawing here uniformly charged sphere. Uniformly charged sphere. Suppose this is a charged sphere. Okay, distance from the center uniformly charged. That is, in all the directions there is a charge. So if it is charged in all these, then what happens? This is the center. This is suppose R, and this is the distance from center. The distance is smaller at P point. So as it is charged, there is a theory. I have explained it very clearly. You can go through in another videos and this channel, where you will get the explanation regarding this non-conducting or dielectric material for which the charge सारे के बॉडी में डिस्ट्रीब्यूट रहता है, तो उसके बदले में इसका जो इलेक्ट्रिक फील्ड होता है यहाँ पे सरफेस से बाहर, यहाँ पे धीरे धीरे यहाँ से यहाँ पे मैक्सिमम होता है, यहाँ से दूर में जाओगे तो घटेगा, यहाँ से सेंटर में आओगे तो फिर घटेगा. बट जब सरफेस से दूर में जाओगे तो ये इलेक्ट्रिक फील्ड वेरी करेगा 1/r² पे, और आप यहाँ से अंदर आओगे तो अब ये वेरी करेगा, E अंदर में वेरी करेगा, वेरीजेस 1 वेरीजेस r. Okay, so the it is very directly, it is inversely of square of this. So the graph would be like this. If I draw a graph here, so up to this r, it will go straight up to this r, distance, to go straight, and after that it will decline like this. So the correct curve is option C. Hope it is clear to you. If you need more clarification, you may write on the comment section for this. Let us go for the answer is C. Next question. Next question is, 4 particles are placed at the vertices of square as shown in the figure. An electron that is free to move is placed at the exact center of the square. In which direction will the electron move? यहाँ पे क्या बोला? Okay, let the options are like this. So ये क्वेश्चन समझने के लिए देखो, यहाँ पे एक स्क्वायर जैसा प्लेस है, यहाँ पे अल्फा पार्टिकल रखा हुआ है, यहाँ पे अल्फा, बोथ आर सेम चार्ज. यहाँ पे रखा है बीटा, इट इज एक्चुअली प्लस चार्ज, ये भी प्लस. Beta it is minus charge. It is here put minus charge. Now, if you put an electron here, this would be, ये इससे attracted होगा, ये इससे भी attracted होगा. So these two force, this and this are equal, so they will cancel each other because this is a negative charge, this is a positive charge. So ये तो attract ही करेगा ना, ये cancel हो जाएगा. Now come to this point, ये बीटा माइनस इस इलेक्ट्रॉन को ऐसे पुश करेगा इस तरफ, और ये P प्लस जो चार्ज है ये इसको इधर खींचेगा. सो दिस फोर्स दोनों इसको डी की तरफ भगाएगा. सो ये इलेक्ट्रॉन जो है वो डी की तरफ जाएगा. सो आई थिंक इट इज वेरी क्लियर टू यू. सो द आंसर वुड बी It will move towards D. Hope it is clear. Go to the next question. A proton moving at a constant velocity enters the region between two charged plates as shown below. Which of the paths shown correctly indicates the proton's trajectory after leaving the region between the charged plates? ये अंडरस्टैंडिंग करने के लिए आप लोगों को ये ऑप्शन में दे देता हूँ, पाथ ए, पाथ बी, पाथ सी, पाथ डी। सो यहाँ पे क्या कहना चाह रहा है ये देखो, ये ट्रेजेक्टरी किधर को होगा, यहाँ पे पॉजिटिव चार्ज इलेक्ट्रॉन आ रहा है, नेगेटिव, तो ऑब्वियसली ये जब आएगा पॉजिटिव, ये बी की तरफ जाएगा नहीं क्योंकि पॉजिटिव पॉजिटिव को रिपेल करता है, ये सी सीधा तो जाएगा नहीं, इसका भी कुछ वेट होगा बाहर निकालने के बाद, ये जो डी नेगेटिव, तो नेगेटिव को अटैक करेगा ना, तो ये जब चल चल रहा है ना, तो ये इधर से आके बाहर निकल इधर आएगा, तो ये डी की तरफ जाएगा। सो होप इट इज क्लियर टू यू। नाउ वी may go to the next question. So let us go to the next question. According to the Gauss law, electric field of an infinite long state charged wire is proportional to लॉन्ग चार्ज हो तो ये 1/r के साथ प्रोपोर्शन होता है। इसका भी थ्योरी का एक्सप्लेनेशन मिल जाएगा मेरा यूट्यूब वीडियो में, आप लोग सब्सक्राइब कीजिए, विल गेट द नोटिफिकेशन। मैं जितना भी वीडियो अपलोड करूंगा तुरंत आपको नोटिफिकेशन मिल जाएगा। अगर आप मेरा यूट्यूब चैनल रेगुलरली फॉलो करते हो देन आपको लोगों का एग्जाम का रिजल्ट जो है ना बहुत अच्छा होगा, ये मेरा गारंटी है। ओके, नाउ ए बॉडी कैन बी नेगेटिवली चार्ज बाय, कैसे एक बॉडी को नेगेटिवली चार्ज कर सकते हैं, क्या उसमें इलेक्ट्रॉन डाल दोगे तब होगा, या इससे इलेक्ट्रॉन लेके जाओगे उठा के तब, या कुछ प्रोटॉन डाल दोगे या कुछ न्यूट्रॉन डाल दो यहाँ से रिमूव करोगे, तो डेफिनेटली कुछ इलेक्ट्रॉन देना पड़ेगा। नाउ क्वेश्चन नंबर 27, a metallic solid is placed in a uniform electric field. The line of force will follow the path shown in the figure. See, this is a very important question, कोई बार आ चुका है एग्जाम पे। देखो, कभी जब कोई इलेक्ट्रिक फील्ड किसी में एंटर करता है, कोई भी एरिया में, सर ऐसा हो सरफेस राउंड हो, जब भी इलेक्ट्रिक लाइन एंटर करता है ए मेटालिक सॉलिड प्लेस्ड, ओके, तो इसमें परपेंडिकुलरली एंट्री होगा, परपेंडिकुलरली, ओके, परपेंडिकुलरली ऐसे, this is the center, so this is the perpendicular, this is with the, this is the surface vector, surface vector is toward outward, so electric field will go perpendicular with this surface area, okay. So here you see, here this is the surface area, it is not perpendicular to this, here it is, here it is perpendicular, here it is not perpendicular, so the line which is perpendicular, this would be the proper answer. So here the answer would be option D. These 4, you see, it is perpendicular with this. Got it? Now come to the next question. A few electric field lines for a system of two charges Q1 and Q2 fixed at 2 points on the x-axis are shown in the figure. This line suggests that Q1 greater than, that is the value, magnitude of the Q1 is greater than Q2, magnitude of Q1 is greater than less than Q2 at a finite distance to the left. ये Q1 से लेफ्ट में कुछ दूर में इलेक्ट्रिकल जीरो होगा, या at the finite distance to the right Q2 जीरो होगा। See, यहाँ पे हम जानते हैं सब लोग कि इलेक्ट्रिक फील्ड लाइन जितना ज़्यादा होता है कोई भी जगह पे, इसका इलेक्ट्रिक फील्ड स्ट्रेंथ जितना ज़्यादा होता है, इलेक्ट्रिक फील्ड लाइन कम होगा, इसका मतलब इसका स्ट्रेंथ कम। सो डेफिनेटली हियर number of electric field line is very less, but here it is very more large number of electric fields lines. So Q1 definitely greater than Q2. And if I go Q से अगर लेफ्ट में यहाँ पे आता हूँ तो इसका जो इलेक्ट्रिक फील्ड होगा, अगर Q2 से मैं दूर जाता हूँ उतना दूर, वहाँ पे ज़्यादा कम होगा definitely because Q2 is less than the Q1. So here option A and option B is correct. At the finite distance to the right of the Q2, the electric field is zero. Okay, so hope this explanation of all the questions will help you a lot in your exam. The video कुछ थोड़ा बड़ा हो गया बिकॉज मैं इसको एक्सप्लेनेशन करता हूँ, बिकॉज एक्सप्लेन नहीं करूंगा तो आप लोगों को समझ भी नहीं आएगा। तो इसका एमसीक्यू का जो सेशन है, ये एमसीक्यू का सेशन फ्रूटफुल नहीं रहेगा। अब ये एक्सप्लेन हो गया तो क्वेश्चन किसी भी तरह घुमा के भी आएगा ना, तो आप लोग आंसर कर सकें। सो होप दिस विल हेल्प यू अ लॉट। अगर आप लोग फील करते हैं कि इट विल हेल्प यू, सो प्लीज सब्सक्राइब माय चैनल and also share this video to your friends so that they can also get the benefit out of it. So thank you. Bye bye for today's session. I'll come back again with a new video. Thank you.